right, listen up here. I'll explain those two sheets. Like I said, make sure you have them available and, something to take notes on as well. Most of you got this, and from it looked like it was correct. It is all real numbers. You do 3x plus 12 minus 2 equals 5x plus 10 minus 2x. You get 3x plus 10 equals 3x plus 10. A lot of you just stopped right there. Here's what you got. You got the same thing on the left, same thing on the right. So it means that if I plug in any number, it's going to make both sides equal, right? So x equals all real numbers. And this is called an identity. Okay, it's called an identity. Everything works. Now, what are we doing today? We're proving what? Trig identity. We're proving trig identity. This is an algebraic identity. Okay, so this is going to have some similarities to this. All right. So section 6.1, we want to verify identities. I'm not going to ask you to solve equations. I'm not going to find the answer, but we're going to show whether something's an identity or it's not. Now, part of that process uses facts we already know. Facts which you can call identity. This is the left side of the sheet. You've seen all of that at some point, and we've either proved it or talked about it. The right-hand side is for later sections. So if you know the cosine sum formula, then you're pretty good already. Now, you can work to prove it. That would be a good little task for you. But for right now, don't worry about the right-hand side. Left-hand side, you're going to need to know those. All right. Reciprocal identities. Cosecant equals 1 over sine. Sine equals 1 over cosecant. So if I ever have a cosecant, I can replace it with 1 over sine. If I have a secant, I can replace it with 1 over cosine. Cosine can be replaced with 1 over secant. All of those are interchangeable. Quotient identities. Oh, this sheet here. Do not lose it. Okay. You need to keep it probably through calculus next year. Don't come back to me and ask for another one. Okay, when Mr. Westfall or Mr. Laverick don't give you one because they say you should already know these. Okay, so save these for next year. Don't ask me for another one, or at least have a good friend that'll keep one for you. Quotient identities. Tangent of x is sine over cosine. Cotangent to cosine over sine. Those come up a lot. Those come up a lot. And I know it was fairly new the first time we went through them. Pythagorean identities. Okay, that next little row. Sine squared plus cosine squared equals 1. Okay, we showed that with the right triangle. And then we can go from there and get 1 plus cotangent squared. We can get 1 plus tangent squared. Even and odd functions, or the even and odd identities. Cosine and secant are the only two even functions. Sine and tangent, cosecant and cotangent are odd, which means sine of negative x equals the opposite side of x. That'll come up at some point. Okay, Pythagorean identities. I do want to, and then you got the cofunctions there at the bottom. We do need to write a couple things down. I put this down in your notes. So start with sine squared plus cosine squared equals 1. Sine squared plus cosine squared equals 1. All right, what other facts can we take from that little equation? What I mean by that, there's two other main facts. Is sine squared of x. What do I get when I solve the original for sine squared? What do I have to do to both sides? I have to
subtract cosine squared.
So what does sine squared equal?
1 minus cosine squared.
1 minus cosine squared x. Okay, that's going to be really important. You're going to need to know. You're going to need to know. And I guess when I say know, that means memorize. You're going to need to memorize these 3 facts right here. You need to know sine squared plus cosine squared equals 1. You need to know sine squared equals 1 minus cosine squared. And what's cosine squared x going to equal? It's going to equal 1 minus sine squared. So starting at the top, 1 minus sine squared. Okay, so from sine squared plus cosine squared equals 1, we get these other two facts. Now, these next two you're not going to be as familiar with, and these are more things that you'll probably have to look up. If you remember them, great, or if you can kind of derive them, great. You need to know those top three. All right, but what other two facts can I generate from 1 plus tangent squared equals secant squared? I can say tangent squared of x equals secant squared of x minus 1. And then the next one would be, I'm going to start with, I'm going to get the 1 by itself, but I'm going to start with secant squared of x minus tangent squared of x equals 1. And then here's the third one. Go ahead and think what other two, or list what other two facts we can generate from there. So if 1 plus cotangent squared equals cosecant squared, I can say cotangent squared of x equals cosecant squared of x minus 1. And then I would say cosecant squared of x minus cotangent squared of x equals 1. When you come across, like if you got a 1 minus something squared, or a 1 or something squared minus 1, or 1, like that is there's a good chance that's a Pythagorean identity. You can replace it with something else. Okay, so you always got to stop and think, all right, can that be replaced with an equivalent identity? Okay, so if I got, secant squared minus 1, stop, say, all right, maybe that's tangent squared. But the top three, like I say, you need to know. You need to know. All right, now let's take a look here. Write down this first one. You need to work straight down. You do not work across. It doesn't work for these. I'll explain why. But write that down. Make sure you have a little bit of room. This one doesn't take very many steps, but some of them will. Get your little half sheet of paper out. All right, now this, let me get out my calculator. Go and pull out your calculator if you have it. I'm in degrees. I'm in degrees. Now, when you're verifying some trig identity, if it is an identity, that means every answer works for it. And we just have to break it down to get the left side equal to the right side. So if you want to test it, what you could do is say secant of an angle, which would be what? 1 divided by, let's pick any angle. Oh, give me an angle. Hey, give me an angle. What? That's a good angle. 30 degrees. So 1 over cosine of 30 plus 1 divided by 1 divided by cosine of 30. So that all equals that, right? So if this is right, what should 1 plus cosine of 30 equal? So 1 plus cosine of 30. Same thing, right? Now, so this should work for any angle. So you give me 30 degrees. What about 300 degrees? So just real quick. What is 1 divided by cosine of 300? Okay, take that answer. Add 1. And then I divide that by what? I divide that by 1 divided by cosine of 300. I get 1.5. What is 1 plus cosine of 300? 1.5. No matter what angle you pick, that left-hand side is going to match up with the right-hand side. But we got to prove that. Now, just because you use two examples, that doesn't prove it. It just shows for two examples. So if you say all real numbers, you'd have to prove it for every real number, which that's impossible. All right, so if you look at your little half sheet, let's kind of go through here. This is actually, I like this. It does a good job explaining. To verify that a given equation is an identity, okay, we're not solving it, it doesn't say solve, it says verify it's an identity. We transform one side of the equation into the other side by a sequence of steps, each of which produces an identity. So basically, we want to do like we did on this algebra one. We want the left-hand side to match the right-hand side. 3x plus 10 equals 3x plus 10. But I got to do it with this. So I got to get the left-hand side equal to the right-hand side. The steps involve maybe algebraic manipulations, which means you add, subtract, multiply, or divide, or maybe known identities. Okay. Note that in verifying identity, we do not just perform the same operation on both sides of the equation. All right, what that means, we're not solving. You can only work on one side of the equation at a time. You can never move something from the left to the right or the right to the left. The two sides remain separate at all times. Okay, so you cannot subtract cosine of theta on both sides. Okay, we don't know whether this is true. We're trying to verify it. Okay, so it is not solving an equation. All right, here are your guidelines. You can do any algebraic operations. You can add two things together by combining fractions, which means you got to get a common denominator. Or you can use fundamental trig identities. So if you got a cosecant, you can replace it with 1 over sine. Okay, anything like that. All right, steps to verify. These are just kind of general guidelines here, because how you go about it will be different for each one, but these give you just some guidelines to follow. Okay, it says number 1, start with a more complicated side. Number 2, stay focused on the answer. I'll try to explain what that means. Number 3 is very important, convert to sines and cosines. Okay, writing one side of the identity in terms of sines and cosines is awful helpful, and I'll show you what that means. You can work on both sides, but independently. And then step 5 is just use conjugates. We'll get to that part tomorrow. All right, how can I prove that the left-hand side is equal to the right-hand side? Sometimes they're really easy, and sometimes they're really fun. That means hard. I consider it fun. All right. Now, cannot move from one side to the other. You can use anything algebraic. You can add things together. You can use any algebraic properties you used before, and you can use any identities that you used before. Like I said, sometimes somebody might solve it in 2 steps, or it takes somebody 8 steps. Doesn't matter as long as you get there. All right. In this case here, if I have a fraction, x plus 5 over y, can I rewrite that as x over y plus 5 over y? Is that algebraically correct? Yes. All right. So what would that look like in this case here? So I can take that and split it up. Cooper.
That would, first it would look like secant theta, 1 over secant theta, plus 1 over secant theta is equal to 1 plus cosine theta.
Okay. Now, you don't even need to mess with that other side if you don't change it. And I know what you're doing, but you don't even need to. So this is totally separate. Also, what you need to do is you need to show your steps, which means don't skip things because you're doing them in your head. Because you remember, I'm grading this, and you're doing this for me, not for you. Like if you want to do that on the side and figure that out, that's fine. But don't just jump down and make this a 1. Show me what you're doing. Okay. Well, what is that? Secant theta divided by secant theta is what? 1. And what is 1 divided by cosine of theta? What is that identity? That's why you have to have that identity sheet handy. 1 divided by cosine of theta equals secant of theta. Or wait, that shouldn't be cosine of theta. Screwed that up. That's why you're looking at me crazy. That has to be secant of theta, right? Sorry. What's 1 divided by secant of theta? Cosine of theta. We're done. Okay, that's all it's saying. You've proven the left-hand side is exactly the same as the right-hand side. So no matter what value you plug in, you've got to get the same It's gotta be true. So it's an identity. We're not solving an equation, we're just verifying whether it's true. The hard part is if it's not an identity, you gotta find something that you plug in doesn't work. We don't typically mess with that. I don't try to do that to you. All right, that's it. That's the idea. But now they're coming all kind of different shapes and forms and difficulties. All right, copy that down. All right, as I look at my steps, okay, the steps to follow. Number one says, start with the more complicated side. Well, which side is more complicated, left or right? Left. The right-hand side is just a cosine. There's really not much you can do with that. Stay focused on the answer. That's just kind of something you got to do throughout the whole problem. You got to understand what you're working towards. All right. Convert the sines and cosines. All right, at this point, as you look at it, is there anything you can do to that? You're secant of theta minus tangent of theta over sine of theta. Is there any way to combine that as it is? Not that I know of. When you get to this point and you're kind of stuck and there's nothing that you can do, you absolutely must do this next step before giving up. And that is step 3. It says convert to sines and cosines. Anything that is not written in terms of a sine or cosine, you rewrite it. What that means is, how can I rewrite secant of theta? What is that equivalent to? 1 over cosine of theta. So you write it in that term. Now, tangent of theta. Some of you will say, well, tangent of theta is the same as 1 over cotangent of theta. Don't do that. That might work like 1 out of 100. Convert the sines and cosines. What's tangent of theta the same as, though? Sine over what? So convert it to that. So sine over cosine. So sine of theta over cosine of theta times sine of theta. You don't even need to mess with that right-hand side. You don't need to keep writing it to the side there. I mean, you can if you want to, but it's not necessary. Now you got to take a look and see, all right, can I combine them in any form from here? Can I condense them? Can I add them? Can I subtract them? Well, can you, see right there, tangent times sine, I can't simplify that, but sine over cosine times sine, I can simplify that to what? I can multiply those two together. Go to look, you know what it would be?
Would be sine squared theta over cosine.
It would be. Don't forget, this is like over a 1. So it's 1 over cosine of theta minus sine squared theta over cosine of theta. Okay? Well, your job now is to do the math. And the biggest mistakes you're going to do, or the biggest things that show up, if you make an algebra mistake. Because if you make an algebra mistake, then you're going to miss the rest of the problem. You can't recover. You almost have to restart and double check your algebra. Okay. Well, I'm just going to write this as 1. They both have a denominator cosine, right? So I can just rewrite that as 1 minus sine squared over cosine of theta. Now this is where the step 2. What's step 2 tell us to do? Focus on the what? Stay focused on the answer. So you got to say, all right, what am I trying to get to? I want this to equal cosine of theta. How can I do that? Well, I mentioned it earlier, but it won't sink in until you do these for a while. But anytime you got a 1 and something squared, it's very well could show up in a Pythagorean identity. And this one does. And this is one of those 3 that I went over. What does 1 minus sine squared equal? Cosine squared. Okay? You don't have to, like in your old geometry proofs, you don't have to, justify every step, because I'll know whether it's right or wrong. If you want to for yourself, like you can over here at any point. And that's why you have to show me your steps. That is your justification. Don't jump from step 2 down to step 5 and make me put in all the work. Okay, cosine squared. Now what happens here? That cancels the square. There's 2 of them up there. There's 1 down here. So that just means I get cosine of theta. Now am I done? The left-hand side equal the right-hand side? Yep. That's our point. That's the whole thing. You're proving that they're the same. You gotta go through this series of steps to find it, but that's the idea.
So do you have to keep, like the right side was cosine theta? Do you have to keep it, or can you manipulate the right side to?
You can manipulate both sides because if you take a look at step 4 there, it says work on both sides. So like if you get to a point on the left-hand side and you're like, I'm stuck, I cannot make it match, you can work over there. You just cannot work with them, like you cannot move the secant over to that side. So in this one, there's not a lot to work with, but yes, you can work and you can manipulate both sides independently, okay, to arrive at two different, as long as they're the same. All right, take a look at the third one. All right, like I said, these are the ones that are used the most. Sine squared plus cosine squared equals 1, 1 minus cosine squared equals sine squared, and 1 minus sine squared equals cosine squared. So I'm just gonna have them up there so I can refer to them. Now you gotta watch. That says 1 minus 2 cosine squared. That is not equivalent to this. You cannot replace that one. Okay, that is not equal to sine squared. That's different. It's close, but it's not the same. All right, any ideas what I can do here? Jacob, any ideas?
Multiply it out.
Do the math, multiply it out. Like you're there, you got a FOIL problem, FOIL it out, see what happens. On some of these, you're gonna take steps, you just gotta take some trial and error. Sometimes it'll be an error. And then you kinda gotta go back and see if you can figure it out. It's kinda like a puzzle. Those of you that like doing puzzles like this, those of you who don't like puzzles, you still gotta do it anyway. FOIL it out. Sine squared times sine of x is sine squared x. Sine of x times cosine of x is plus sine of x times cosine of x. Cosine minus sine of x times cosine of x minus cosine squared of x. All right, simplify it as best you can. What happens to those two middle terms? Add up to what? Two middle terms add up to 0 because you got sine of x cosine of x minus sine of x cosine of x. So I should have sine squared x minus cosine squared x. All right, this is where you kind of got to keep looking over on the other side. Like, all right, how do I get there? How do I get there? Here's where I'm at. How do I get to that piece on the right-hand side? Anybody got any ideas? What do you got, Adam?
Sine squared of x is equal to 1 minus cosine squared x.
All right, good. Cosine squared is equal to 1 minus sine squared, but that wouldn't make sense here because this one is just in terms of cosine. So I wouldn't want to introduce more sines. I want to say, all right, this one doesn't have any sines. How do I get rid of that? I can take this out, and I put in 1 minus cosine squared x minus cosine squared x. And that is really my last step because those two together will give me 1 minus 2 cosine squared x. Okay. 1 minus 2 cosine. Am I done? Yep, matches the right-hand side. Okay, so I have not had to manipulate it. Today, I don't think we have to manipulate the other side just because we're starting out. But we should be able to work with one side to get to the other. So there you go. You're good there. All right, copy this one down. Oops, why did I erase it? 1. There's a quick way and a not so quick way on this one. First thing I'm take a look, anytime you got a 1 and you got something squared, does it show up as one of your identities? Okay. And is 1 plus tangent squared one of our identities? Hopefully we see that. Yeah. What does that equal, Tyler? Secant squared. So this right here, so I got 2 tangent of theta over secant squared theta. Okay? And like I said, just for like my personal notes, you might say 1 plus, or your personal notes. And you can use that step if needed, I mean, but I'll be able to decipher that. All right, where can you go from there? Cool.
You can make the tangent sine theta over cosine theta,
And then what else would you do?
and then the secant could become 1 of the cosine theta.
Okay, you got it, like right here. I'm stuck. There's really nothing I can do. You cannot just leave that problem until you convert everything to sines and cosines. You've got to do that step. So you got a tangent. What can I rewrite that as? I got a secant. What can I rewrite that as? You absolutely have to do this step. You cannot stop short of it. So 2 sine of theta over cosine of theta over. Now secant squared is just 1 over cosine squared. Now this next little piece comes up a lot. You dividing fractions. Okay, keep, change, flip. Go back to Mrs. Hayner, whoever you have. Keep, change, flip. Keep the top, change to multiplication, flip the bottom. We do this over and over and over on this one here. Now, what is 2 times sine of theta over cosine of theta? All right, now this is just a side note. Don't write this down, but this is always an issue, and if you make this mistake, then you are done. You cannot finish this problem. Is it 2 sine of theta over cosine of theta, or is it 2 sine of theta over 2 cosine of theta? Okay, those are kind of the only 2 things I ever see. Does the 2 go to the numerator and denominator, or numerator only? Numerator only, because it is really 2 over 1. That's how you want to think about that. So this is really 2 over 1, and it multiplies it straight across. So if you do this, okay, then you're going to be just stuck. Nothing you do will fix it. Okay, that's when you go back and say, all right, I think I made an algebra mistake. So now this becomes 2 sine of theta over cosine of theta times, flip this one, cosine squared theta over 1. I'm going to get rid of all this because that was just extra. Now it's a multiplication. When things are being multiplied, you want to cancel anything that can cancel. And so I would cancel that cosine squared with that cosine. And what are you left with? I'm left with 2 sine of theta times cosine of theta. Is that what we wanted? So we're done. So again, watch. If you make an algebra mistake, if you can't get everything to work out, you got to go back and see if you made an algebra mistake for that. All right, don't worry. I'm going to do the same problem again. You can just watch if you want. You can copy it down if you want. I don't care. But I said there's more than one way to do it. That was probably the quick way. But in reality, 1 plus tangent squared equals secant squared. I'll be honest with you, about 30% of you will recognize that equals secant squared. Well, how are the other 70% going to solve it? Okay, there's another way to go about that. So if you don't think about it, or you don't see it, or you don't have that memorized, what do you got to do before you quit a problem? You got to convert it to what? Sines and cosines. So I'm going to convert that right now to sines and cosines. Okay, because 70% of you will do that. That'll be your first step. So it'll be 2 sine of theta over cosine of theta over 1 plus. Now tangent squared would be sine squared over cosine squared. Now from here, at least participate. If you're not writing it down, at least participate. How would I go about solving this? Start with that denominator. It's a little bit uglier. How do you add those together? We got to get a common what? Denominator. Okay, so 1 plus sine squared over cosine squared. And I'm gonna make this 2 sine of theta over cosine of theta. And then what does this 1 become? That becomes cosine squared over cosine squared plus sine squared over cosine squared. Since they have a common denominator, I can write them as 1, which we'll do in here in a second. The top, I can't do anything else with that. So I'm just gonna make that 2 sine of theta over cosine of theta. All over cosine squared theta plus sine squared theta over cosine squared theta. What does that equal? What does that equal? 1. Same as sine squared plus cosine squared, we just flipped it. So that, so sine squared theta plus cosine squared theta equals 1. So all right, so I'm going to kind of do, and there's times you can do 2 steps in one as long as it's logical. I'm going to do that here. I'm going to make this 2 sine of theta over cosine of theta times. I'm going to flip that and make that 1. And so now we're back where we were, right? It's exactly the same spot. That cancels with that. I'm left with 2 sine of theta times cosine of theta. Like I said, if you recognize that it's 1 plus tangent squared is secant squared, you're going to save yourself a couple steps. But in reality, 30% of you will see that, 70% of you will go sine squared, make it sines and cosines. Okay, for that. All right, you want to try one? If you're really not sure, you just write it down. You think you can handle this? Try it. Keep your eraser handy. Can't do that. Just 1 over sine. But you get everything right. All right. Are you stuck? Most of you are probably stuck. Now, a couple little details here. Now, over here, this is one where we can work on the other side, and I actually probably would, because I got a secant squared, and normally, if I can convert something to sine and cosine, I will. Secant squared is 1 over cosine squared. So that's the same as 1 over cosine squared x, which I would just make as 2 over cosine squared x, and then I'm just leave that till I get a little bit further. An algebra thing, and I saw more than one person do this, so I want to at least address this. We talked about on the first problem, I think it was, I had like 1 plus sine of theta over, I'll just make something up, cosine of theta. You can break that up into 1 over cosine of theta plus sine over cosine if it helps you. You can do that, but you can't break up a single term over 2 terms. So like if you got 2 over x plus y, that is not the same as 2 over x plus 2 over y. So if you got one term here, split it up's fine. But if you got 2 terms in the denominator, you can't split it up. Okay. All right, now, with that in mind, sometimes I just say the words, do the math. All right, sometimes easier said than done. Do the math. What's it asking me to do between these two? It's asking me to what? Add them. How do I add them? What do I have to have in order to add them? Common denominator. So I got to get a common denominator. So no matter what, like trying to manipulate it any other way really isn't going to work to my knowledge. Well, how do I get a common denominator? If this has a 1 minus sine of x and that's a 1 plus sine of x, what do I have to add in on this side? I got to add in the 1 plus sine of x, and if I add it in the denominator, I also have to add it in where? On the numerator. So plus, same thing over here, I got a 1 plus sine of x. I need to add in a 1 minus sine of x. I have to add in a 1 minus sine of x. So I'm just going to stop and wait, let you make sure you understand that step. Just getting a common denominator. And I just multiplied the top and bottom by the same thing. Okay. I have a common denominator. I can make this 1 plus sine of x times 1 minus sine of x. Okay, just as 1. And now I can take 1 plus sine of x plus 1 minus sine of x. Okay? This is where you keep the end in mind. You keep a look over here on the right-hand side. This is what I'm trying to get to. I'm trying to get 2 over cosine squared. What does the numerator add up to? You take your time there. What just happens?
It becomes 2.
Just becomes a 2. 1 plus 1 because you got a positive sine of x, a negative sine of x add up to 0. All right, I'm also going to notice I want a cosine squared over here. This doesn't look anything like cosine squared, so go ahead and do what to these two things? FOIL them. FOIL it out. Multiply it. And what are you left with? Now, when I say show your steps, you don't have to show like every little tiny step for the FOILing problem.
1 minus sine squared x.
If you just put 1 minus sine squared x, that would be fine. I would understand that you FOILed them and the 2 middle terms add up to 0. Okay, now we're really close because what's 1 minus sine squared x equal? Cosine squared. So we're really done. So it's 2 over cosine squared. 2 over cosine squared x. And 2 over cosine squared. So I did manipulate the right-hand side a little bit. Okay, to save me a step on the left-hand side, but I should have got there anyway. All right, so that's how you do it. All right, this is a little bit new. These are very similar to the class notes. Sometimes they're just like a minor change. So use your class notes like if you get stuck. I would encourage you to try it without, but then go back to your class notes because they are, like I said, pretty similar. You're not gonna see like anything like really brand new, I don't think.
There's